In this lecture, we will look at the elasticity of supply and the elasticity of demand. After listening to this lecture, you will be able to demonstrate the ability to define the term elasticity, calculate and interpret the price elasticity of demand, calculate and interpret the income elasticity of demand, calculate and interpret the cross price elasticity of demand, calculate and interpret the price elasticity of supply. Elasticity is the measure of how responsive demand is for a good or the supply of a good is to changes in the price of the good, changes in the price of another good, or changes in income. There are 4 types of elasticity this lecture will look at: price elasticity of demand, income elasticity of demand, cross price elasticity of demand, price elasticity of supply. The price elasticity of demand measures the percentage change in the quantity demanded in response to a 1% change in price. What this really is saying is that the suppose of a price of a good increases by a penny. What happens to the quantity demanded? Does it increase by a large amount or by a small amount? Does it decrease by a large amount or a small amount? The measurement is interesting to firms because products that they might be interested in selling will have an impact on what they charge for the product. Elastic demand means that the price elasticity is less than -1, and increases in price will lead to large decreases in the quantity sold. Unit elastic demand means that the price elasticity is equal to -1, and increases in price will lead to unit decreases in the quantity sold. Inelastic demand means that the price elasticity is less than 0 and greater than -1, and increases in price will lead to small decreases in the quantity sold. In the graph, we have a standard linear line demand curve. The price elasticity of demand will change over the demand curve as one moves down the demand curve. The top portion of the demand curve will be price elastic. Second, there will be a point of unit elasticity. Third, there will be a region of price inelasticity at the bottom portion of the demand curve. One point to note is that as the point of unit elasticity will change depending on the steepness of the demand curve. In addition to all 3 types of elasticity appearing on one graph, there are some demand curves that exhibit one of the 3 characteristics more pronouncedly than others. Let's take a moment and look at these 3 special demand curves. The first demand curve is the vertical demand curve. The price elasticity of demand is 0 because the price changes and the quantity is fixed. Economists would say that this demand curve is perfectly inelastic. The second demand curve is a relatively inelastic one. The reason why this demand curve is relatively inelastic is because the demand curve is fairly steep, and it is closer to the vertical demand curve, which is inelastic. It is important to note that the relatively inelastic demand curves do have places where it is elastic. However, most of the demand curve is inelastic. The horizontal demand curve has an infinite elasticity because only the quantity changes. If you were to calculate the price elasticity of demand, as you will do so in a few minutes, you will see that the percentage in change in price is always 0. And it turns out you will divide by 0, which means that we end up with infinity on the bottom. economists would say that this demand curve is perfectly elastic. The fourth demand curve is a relatively elastic demand curve. The reason why this demand curve is relatively elastic is because the demand curve is fairly flat and is closer to the horizontal demand curve, which is perfectly elastic. It is important to note that the relatively elastic demand curves do have places where they are inelastic. However, most of the demand curve is elastic. The final special case is this demand curve, which has unit elasticity, meaning the price elasticity is always 1. The point of elasticity will move up or down the demand curve depending on the steepness or the flatness of the demand curve. Notice the point elasticity, unit elasticity on the graph on the left. The point of unit elasticity is not at the center of the line like the graph on the right, but closer to the bottom portion of the demand curve. Also notice the inelastic portion of the demand curve on the left takes up the majority of the demand curve, whereas the region of inelasticity on the right is roughly about half the demand curve. Economists would say that the demand curve on the left is an inelastic demand curve because most of the demand curve is inelastic. As mentioned before, the point elasticity will move up and down the demand curve depending on the steepness or the flatness of the demand curve. Notice the point of elasticity on the left. The point of unit elasticity is not in the center like the graph on the right, but closer to the top portion of the demand curve. Also notice the elastic portion of the demand curve takes up the majority of the demand curve on the left. Economists would say that the demand curve on the left is an elastic demand curve because most of the demand curve is elastic. If you compare the inelastic demand curves with the elastic demand curves, it is obviously that it's the steepness or the flatness of the curve that makes a curve an inelastic demand curve or an elastic demand curve. Next, we'll look at calculating the price elasticity of demand. There are 3 ways that the elasticity of demand can be calculated. 1. Using calculus. Economists usually use a mathematical equation which describes the elasticity and use calculus to calculate the elasticity. Another method, which is often used in textbooks, is calculating the arc elasticity. The calculation uses an average of the price change and an average of the quantity change. The last item is using point elasticity. Point elasticity is often used in textbooks for calculating elasticity. This method of calculation will be used in this course. The formula for the price elasticity of demand is the percentage change in the quantity demanded divided by the percentage change in price. While the general formula is useful, we will use the formula Q2 minus Q1 divided by Q1 divided by the quantity of P2 minus P1 divided by P1 to estimate the price elasticity of demand. Please remember that the subtractions are done before the divisions because the parentheses indicate that these calculations need to be done first. Another point to remember is that the big division bar acts like a parenthesis, so you will need to do the top division first, then do the division below the bar second, and then divide the top by the bottom. Let's take a moment to look at the variables involved in the calculation. Q1 is the starting quantity of the good. Q2 is the ending quantity of the good. P1 is the starting price, and P2 is the ending price. The procedure for calculating the price elasticity of demand is as follows. Write down the formula for calculating the price elasticity of demand. 2. Write P1 to the first price listed in the problem. Write Q1 next to the first quantity listed in the problem. Write P2 next to the second price listed in the problem. And write Q2 next to the second quantity in the problem. Substitute the values for P1, Q1 into the formula, and then substitute the values for P2 and Q2 into the formula. Subtract Q1 from Q2, subtract P1 from P2, divide the difference of Q1 and Q2 by Q1, divide the difference of P1 and P2 by P1, divide the result of steps 8 and 9, and interpret the result. Let's look at an example of the elasticity of demand being calculated. A marketing researcher of a compact disc manufacturer discovers when the firm charges $9 for a pack of 25 blank CDs, it sells 100 million packages. When the firm increases the price of the package of CDs to $11, the firm sells 80 million packages. The manufacturer would like to know the price elasticity of demand for CDs to better predict how changes in price will impact the amount of discs demanded. The first step is to locate P1 in the problem. In this problem, we are told the firm charges $9 for a package of 25 CDs when it sells 100 million packages. This statement indicates that this is the starting point for the problem. Thus, $9 is going to be the starting price. You may want to write P1 near the $9 to help you remember that it is the starting price. Since the part of the statement also gives information about the initial quantity, write Q1 near the 100 million packages. Next, notice there's a statement about the firm's changing the price. When the firm increases the price of the package of CDs to $11, the firm sells 80 million packages. So we're going to label the $11 with the P2. Also part of that statement on price is a phrase about the change in quantity. So we'll label this as Q2. Once we have the prices and quantities identified and labeled, write down the formula. Next, locate P1 in the problem and in the formula, and substitute the value, in this case 9, into the formula. Locate Q1 in the formula and in the problem, and substitute the value into the formula. In this case, the value is 100 million CDs. Locate P2 in the formula and in the problem, and substitute its value into the formula. In this example, P2 is $11. Locate Q2 in the formula and in the problem, and substitute the value into the formula. In this example, Q2 is 80 million. Next, subtract Q1 from Q2. In this example, subtract 100 million from 80 million. Since 80 million subtract 100 million gives a negative 20 million, we'll fill in negative 20 million into the formula. Next, subtract P1 from P2. In the example, P2 is $11 and P1 is $9, so subtract $9 from 11. After subtracting $9 from $11, 2 replaces the subtraction. Next, divide the difference between Q2 and Q1, minus 20 million in this example, by Q1, 100 million in this example. The division is replaced by minus 20 in the numerator, or the number on the top. Next, divide the difference of P1 and P2 by P1. In the example, the difference between P2 and P1 is $2 and divide it by $9. This gives 0.22 rounded off to 2 digits. Next, divide the numerator, the top number, by the denominator, the bottom number. So the price elasticity of demand is 0.90909090. Before finishing the problem, let's round off to 2 decimal places. To round off the number to 2 decimal places, locate the third decimal place. If the number in the third decimal place is greater than 5, then add 1 to the second decimal place and drop the remaining decimal places. If the number in the third decimal place is less than 5, drop all the decimal places to the right of the second decimal place. Let's start by counting off 3 spaces to the third decimal place. To round off the number to 2 decimal places, locate the third decimal place. If the number in the third decimal place is greater than 5, then add 1 to the second decimal place and drop the remaining decimal places. If the number in the third decimal place is less than 5, then drop all of the decimal places to the right of the second decimal place. If you start counting places from the first number to the right of the decimal place, 1, 2, 3, you'll see that the third digit is a 9. Since 9 is greater than 5, you'll add 1 to the second decimal place, 0, and drop all of the remaining decimal places. Our final answer is the price elasticity of demand is minus 91 hundredths. Thus, the price elasticity of demand for the firm CDs is minus 91 hundredths. There is one thing to notice, is that the negative sign must be kept. Most economists report elasticities as negative numbers, indicating that there will be a decrease in the quantity demanded. Next, let's interpret this number so we understand what it means. As you remember, there are 3 types of price elasticity. Elastic demand occurs when the price elasticity is less than minus 1, and increases in price will lead to large decreases in the quantity sold. Unit elasticity occurs when the price elasticity is equal to minus 1. Inelastic demand occurs when the price elasticity is less than 0 and greater than minus 1. Let's see whether our calculated value is price elastic, unit elastic, or inelastic. To find out which type of elasticity our calculated value has, we need to compare the value we calculated with each of the 3 types of elasticity. Let's start by looking to see if the value is price elastic. So the question needs to be asked, is our calculated value less than minus 1? Since minus 91 hundredths is not less than minus 1, it does not meet the criteria for being price elastic. Next, let's see if the value is unit-elastic. So the question needs to be asked, is our calculated value equal to minus 1? Since 91 hundredths is not equal to 1, it does not meet the criteria for being of unit elasticity. Next, let's see if the value is price inelastic. So the question needs to be asked, is our calculated value less than 0 but greater than minus 1? And since minus 91 hundredths is less than 0 but is also greater than minus 1, it does meet the criteria for being price inelastic. Thus, the answer to the question is that the firm CDs are price inelastic because their elasticity is less than 0 but greater than minus 1. Total revenue is the amount of money a firm receives for selling a given quantity of goods. The formula for total revenue is price times the quantity sold, or P times Q. Since price elasticity of demand measures the change in the amount of goods sold compared with a price change, the elasticity of the goods will determine whether or not a firm can increase its prices significantly without changing the amount of goods significantly, and by extension, its total revenue. Let's look at a couple of examples. The quantity of the goods sold will decline by 0.05%. This means that the firm will sell 5 fewer units of the good than at the old price. Since the firm will sell 5 fewer units of the good, the new quantity of the goods sold is 10,000 units minus 5 is 9,995. Further, the firm's total revenue is price times quantity, or the new price, $15 times $9,995, giving a total revenue of $149,925. Something got screwed up. This table shows the impact on the firm's revenue. Before the price of the good increases, the firm sold 10,000 units of a good at $10 per unit and earned $100,000 in revenue. After the price of the good increased, the firm sold minus 40,000 units at $15 apiece, and the firm earned a minus $600,000 in total revenue. The conclusion can be drawn from this example is that when the firm produces an elastic good, price increases hurt the firm's total revenue and its profits. Let's look at another example. A firm produces a good which has an elasticity of 1/1000th. The firm sells 10,000 units per year. The firm decides to increase the price of the good by 50%, that is from $10 to $15. What will happen to the sales of its good? The quantity sold will decline by 0.05 of a percent. This means that the firm will sell 5 fewer units than at the old price. The quantity sold will decline by 0.05%. This means that the firm will sell 5 fewer goods than at the old price. Since the firm will sell 5 fewer units of the good, the new quantity of the goods sold is 10,000 units minus 5 units is equal to 9,995 units. Further, the firm's total revenue is price times quantity, or $15 times 9,995, giving a total revenue of $149,925. The table shows the impact on the firm's revenue. Before the price of the good increases, the firm sold 10,000 goods at $10 per unit. The firm earned $100,000 in total revenue. After the price of the good increases, the firm sold 9,995 units at $15, and the firm earned $149,925 in revenue. The conclusion that can be drawn from this example is that when the firm produces an inelastic good, it can actually increase its total revenue and perhaps its profit by increasing the price of the good. This diagram gives an example of how the demand curve impacts the total revenue. As the price of the good decreases, the price elasticity moves from being elastic to inelastic. As a result, for an elastic good, the total revenue increases and then decreases. The table summarizes the relationship between price changes, price elasticity of a good, and total revenue. If the firm increases the price of a good and the good is hence inelastic demand, the firm's total revenue will increase. If the firm decreases the price of the good and the good has an inelastic demand, the firm's total revenue will decrease. If the firm increases the price of good and the good has an elastic demand, then the firm's total revenue will decrease. If a firm decreases the price of good and the good has an elastic demand, the firm's total revenue will increase. If a firm increases the price of a good and the good has unit elasticity demand, the total's revenue will remain unchanged. If the firm increases the price of a good and the good has unit elasticity of demand, the firm's total revenue will remain unchanged.